Okay, this is on relations, functions, and inverses. And this is like the first day of notes on this section 1.6. We'll probably spend 3 days on 1.6. First, and I know we've already talked about it this year, but let's go through it again. Definition, probably the most important definition in upper level math, is a function. Remember, a function is a set of ordered pairs. Okay, and this symbol means such that. Okay, that symbol means the words such that. It's just a shortcut way to write that. It's the backwards epsilon. Such that for every x value, it can be paired for every x value, it can be paired with 1 and only 1 y value. Okay, and graphically, we do the vertical line test to tell whether or not it's a function. We've already done that on the homework. If 2 points line up and down, then it's not a function. Okay, that's the definition that you're used to, okay, for a function. Okay, now we're going to add another definition, and that's what we call one-to-one. Okay, some authors will write it like that, one-to-one. The shortcut is to write it like that, one-to-one. Okay? A relation or set of ordered pairs is one-to-one. IFF, if and only if. No, okay, here's the other test. No horizontal line intersects its graph in more than 1 point. Okay, so a relation is a one-to-one function. Okay, that means it's got to pass, if it's one-to-one and it's a function, it's got to pass both the vertical and the horizontal. Okay, the relation is a one-to-one function, IFF, if and only if, no vertical or horizontal line intersects. A relation is a one-to-one function, IFF, if and only if, no vertical or horizontal line intersects the graph in more than 1 point. Okay, now let me give you a picture. So if I did a graph like this, okay, as long as it passes the vertical line test everywhere, and this one would, and it passes the horizontal, this one is a one-to-one function. It's got to pass both tests. Okay, let me give you one that doesn't. Okay, I probably should draw that. Hang on, I'll draw that a little bit better. I can do better. There. Okay, this one would be okay for a function. It would pass the vertical line test, but it does not pass the horizontal line test. When you have more than one point line up across horizontally, this one is not one-to-one, but it is a function. Okay, it would pass the vertical line test, but it's not one-to-one. For not one-to-one, this part means if I have two different x values that are not equal, the y values are equal. So if I pick, like, say this is x sub 1 and this is x sub 2, the x values are not equal, but the y values are equal. So my f of x sub 1 does equal my f of x sub 2. That's actually the algebraic definition of one-to-one. Okay? Main thing is horizontal line test. That's the easiest way to think of it. Okay? The next thing the author, and we've talked about this in pre-calc, to find the inverse of a function. Okay, algebraically, in function mode, you do two things. You interchange the x and y. Interchange the x and y. That's my and symbol. And then solve for y. And that will be the inverse. Okay, example. Say they ask you to find the inverse of f of x equals 3x minus 2. F of x is the same as y. So I would rewrite it first. I'm just substituting in y in for f of x. Okay, now to find, if they say find the inverse, interchange the x and y. So just switch them. And now solve for y. Get y by itself. So add 2 to both sides. And then divide by 3. Okay, so I end up with y equals x plus 2, that quantity divided by 3. You agree with that? Okay, now, most of the time they won't write it like that. They're going to use the inverse notation. So for this y, they're going to substitute in f inverse of x. Okay, so this would be the inverse of the original. And they write it f inverse of f of x. Okay? Yeah. And if you want to graph it, remember if you graph y sub 1, if we graph the original in y sub 1, and if we graph the inverse in y sub 2, and I would do, I'd probably do zoom 6 and then do zoom square. Remember the inverses should be symmetrical. In y sub 3, I would probably graph the line y equals x. Remember, they should be symmetrical about this line. You should be able to fold them over that line. Okay? To verify that they are inverses, use compositions. You can always check your answers. Okay? What you do is you do f of f inverse of x. And it should always bring you back to the identity. It should always bring you back to x. So if I did f of x plus 2 over 3. Put that x plus 2 over 3 back into the original. You would put this back up in here to the original. So you'd have 3 times x plus 2 over 3 minus 2. The 3's would divide out, right? And the x plus 2 minus 2 divides out, and it brings you back to x. If you get x for your composition, you know you've got the right inverse. You can also do f inverse of f of x. You can put the original back in for, so if we did that, we'd have f inverse of 3x minus 2. So we'd have, put that back in, 3x minus 2. We're going to put it right in here. And then plus 2 over 3. And it brings you right back to x. Okay? Okay, last statement. For a function to have an inverse which is also a function, if you want the original function to have an inverse and that inverse is also a function, the original function must be 1-to-1. Now you might have a function that has an inverse that is not a function. But if you want the original function to have an inverse which is also a function, the original has to be 1-to-1. Okay? Okay. That's as much as I'm going over on that.